In this topic, we're going to discuss classes and objects. Specifically, what is a class? What is an object? We'll provide a brief demonstration showing the difference between the class and the object, and finally give you the opportunity to do some individual practice. A class is a template or blueprint of something that exists in the real world that we want to model in a software system. And a class consists of two elements: data, also known as fields, and methods, also known as behaviors. An object is created or instantiated based on the definition of its class, and multiple objects can be created from the same class. So in this picture, you can see that we've got the cookie cutter that represents the class. It's the specification or the template. And from that, we can create multiple objects based on that specification. Now, once an object has been created, we can access the data and methods of each unique object. If we take a look at an architectural blueprint, that blueprint is an abstract representation of something that ultimately will be brought into existence through the builders. Now, I don't have the ability to move my furniture into that blueprint. That's because it doesn't have any type of tangible dimensions. It's an abstract representation. Only when the house has been created do I have the ability to interact with it. This same type of process applies to a class and an object. The class provides the specifications or the template, and we have the ability to create multiple objects based on that template. Let's say we're asked to work on a banking application that allows our customers to access and manage their checking and savings accounts. We are given the following requirements. As a customer, I can withdraw funds from my account. As a customer, I can also deposit funds into my account. And finally, as a customer, I can get the balance of my account. When analyzing requirements, we want to identify the nouns contained in the requirements. The nouns are oftentimes going to be candidates for our classes in an object-oriented system. So given our three requirements, we identify two high-level class candidates: the customer and the account. After we've identified our classes, we look for any verbs, as these often will be the methods or behaviors we include in our class. We also want to look for any potential data that would be associated with our high-level classes. In our requirements, we identify three methods: withdraw, deposit, and get balance. Associated with the data, we've identified funds and balance. Once we've identified our class and its associated data and methods, we can model our class using a UML class diagram. The UML class diagram is made up of three primary areas. At the top, we have the name of the class itself. In this example, it's the account. Following the name of the class in the middle section are any of our data attributes or fields. In this example, we've identified balance as the data that's associated with the account. The final section contains any of the methods that are going to be contained within the account. In this example, we have a withdrawal, a deposit, and a get balance method. We now have all the information based from the requirements and the design to go about implementing and coding this class. After we've opened up Eclipse, we're going to go ahead and create a new Java project. So go ahead and select New Java Project. And in the project name, we're going to call it Class and Objects. Once the name has been entered, go ahead and click the Finish button. Now that we have our project, we're now going to create our new Java class, and we're going to name it Account based on the UML design on the left. Enter the name and then click Finish. The first thing that we want to do with our account is add the data attribute. In this case, it is a private double with the variable name balance, and we're going to initialize this value equal to 0, and we're going to use the double constructor. We're next going to add the methods. The first method that we're going to add is the public void withdraw method that takes a double as a parameter, which is the funds that will be deducted from the balance. We implement that by setting the instance attribute balance equal to the current value of balance minus the funds parameter value that was passed in. We're now going to add the deposit. So it's public void deposit. And once again, we're going to pass in a double value. We're going to call the parameter funds here because it's just a local variable. And our calculation is going to be the balance is set equal to the current balance plus whatever value the funds represents that was passed in. And finally, we're going to add our getBalance method. In this example, there are no parameters that are passed, but we're going to return the balance itself, which is defined as a double. All right, we'll go ahead and save the account. And you can see that the account in the code now matches the design. We see the balance attribute has been implemented, as well as the three methods: the withdraw, the deposit, and the getBalance. The next thing we want to do is create a new test class. And this is basically just going to exercise the new class that we created. So we're going to call it test, make sure that we add a main method, and then click finish. Within the main method, the first thing that we need to do is actually create an instance or an object of type account. In this example, we're going to call it savings. We use the keyword new, which is required in order to instantiate a new object based on the class. Now, what we're going to be doing here on line 7 is simply printing out the balance of this new object. And you can see in the drop-down here that there are a number of methods that have been defined on the account class: our getBalance, our deposit, and if we scroll down a bit, you can see our withdraw. So what we want to do here is return the balance. So we're going to call the getBalance method. We're going to go ahead and save this and run it. And you can see that it prints out the default value 0.0. The next thing we want to do is actually deposit funds into our savings. So we're going to say savings.deposit, and we're going to pass a value in here of $1,100. What we've done is we've just used a public method to change that private data. Now we're going to print out the value just to verify that the balance has been updated. So once again, we use our savings object and call the getBalance method. We're going to go ahead and save it, run it again, and you'll see that the deposit has been made to this particular savings account in the amount of $1,100. And finally, the last thing we want to do is we want to withdraw funds to make sure that the withdraw method is working properly. So given our instance of savings, we say savings.withdraw, and we're going to take out $600. After that withdrawal has been made, we're going to show the balance again, and we're going to add a little bit of text description here to show exactly at what point this balance is being calculated. So we're going to say balance after withdrawal equals, and once again we call savings.getBalance. We save the file and execute, and now you see that our value is at $500 and it's appropriately been adjusted. Now that you've seen the demonstration, it's now your turn to go about implementing the next class that we have in our example. So what we'd like you to do is analyze the customer class by completing the following steps. First, identify the data and the methods for the customer class. Design the customer class using your UML diagram. And then finally, implement and code the class based on the design. Good luck.